Most people avoid thinking about what happens after they flush. It disappears, right? Out of sight, out of mind. But what if I told you that what we flush holds secrets? Secrets about our health, our habits, even our communities. Scientists are starting to pay attention, and what they're finding is revolutionizing public health. Welcome to the fascinating world of wastewater epidemiology. By analyzing sewage samples, scientists can track disease outbreaks and monitor antibiotic resistance. It's like taking the pulse of a community, but instead of checking blood pressure, we're analyzing what's swirling in the sewers. The beauty of wastewater epidemiology is its anonymity. It provides a snapshot of the entire population, capturing data from those who might not seek medical help. Wastewater epidemiology isn't exactly a new concept. Scientists have been studying sewage for over a century, tracking the spread of diseases like typhoid and cholera. But recent advancements in technology have revolutionized the field. We can now detect incredibly tiny amounts of viruses, bacteria, and chemicals in wastewater, allowing for more precise and timely analysis. Imagine a city battling an outbreak of the flu. Traditionally, health officials would rely on people visiting doctors and reporting symptoms. But not everyone seeks medical attention, and those who do often wait until they're quite sick. Wastewater epidemiology provides an early warning system. By monitoring sewage samples, scientists can detect the presence of the flu virus even before people start showing symptoms. This early detection allows for quicker intervention, such as public health campaigns encouraging vaccination and hygiene measures. It's like having a crystal ball, allowing us to anticipate and mitigate potential health crises. Wastewater epidemiology extends beyond infectious diseases. Consider the opioid epidemic. Traditional methods like overdose reports lag behind the true scope. Wastewater analysis provides a real-time snapshot of opioid use. By measuring opioid levels in sewage, researchers track trends and hotspots. And it's not just illegal drugs, it tracks prescription medications, providing insights into antibiotic use and resistance. Remember the fight against polio? Wastewater surveillance was critical in eradicating the disease. Detecting the virus in sewage helped target vaccination efforts. Wastewater epidemiology provides an unbiased view of community health. It's a powerful tool for tracking disease, monitoring drug use, and evaluating interventions. It's not just germs lurking in our waste. Our poop and pee are a reflection of our lifestyles. What we eat, what medications we take, even the chemicals we're exposed to, it all ends up in the sewer system. Scientists are now using this information to study dietary trends, assess exposure to environmental pollutants, and even monitor stress levels within a population. For example, analyzing levels of artificial sweeteners in wastewater can provide insights into soda consumption patterns. High levels of certain pesticides might indicate agricultural runoff contaminating the water supply. And measuring stress hormones like cortisol in sewage can reveal community-wide stress levels, potentially linked to socioeconomic factors or major events. Essentially, our waste is a diary of our collective lives. By analyzing its contents, scientists can gain a deeper understanding of population health, identify potential risks, and develop targeted interventions. It's a whole new way of looking at public health, using our waste as a mirror, reflecting our shared habits and challenges. Section 5. From Waste to Resource, the role of treatment plants. Wastewater treatment plants are the unsung heroes of public health. We flush, we forget, but behind the scenes, these plants work tirelessly to protect our environment and well-being. They're not just about removing unpleasant sights and smells, they're essential for preventing disease outbreaks and safeguarding our water resources. The treatment process is a marvel of engineering and biology. It involves a series of steps, from physically removing solids to using bacteria to break down organic matter. The goal is to remove harmful pathogens, reduce pollution, and release treated water that meets regulatory standards. But treatment plants are more than just sanitation facilities. They're evolving into resource recovery centers. New technologies are being developed to extract valuable resources from wastewater, such as biogas for energy production and nutrients for fertilizer. This shift towards a circular economy is not only environmentally sustainable but also economically beneficial. Section 6. Cleaning up our act: Advanced Waste Management. As our understanding of wastewater grows, so does our responsibility to manage it effectively. Traditional treatment methods, while effective in removing most pollutants, are not always sufficient to address emerging contaminants like pharmaceuticals and personal care products. That's where advanced waste management systems come in. These systems utilize cutting-edge technologies such as ozone treatment, membrane filtration, and activated carbon adsorption to remove even the tiniest traces of contaminants. They offer a higher level of protection for both human health and the environment. Furthermore, innovative approaches like constructed wetlands and bioreactors are being explored as sustainable and cost-effective alternatives to conventional treatment methods. These nature-based solutions not only purify wastewater but also provide ecological benefits such as habitat creation and biodiversity enhancement. Section 7, to flush or not to flush, a cultural divide. Waste management is not just a scientific matter, it's also deeply intertwined with culture and tradition. Different societies have developed unique approaches to dealing with human waste, shaped by factors like climate, geography, and religious beliefs. In some cultures, dry sanitation systems like composting toilets are the norm. These systems divert human waste from the water supply, turning it into valuable fertilizer. In other parts of the world, flush toilets and centralized sewage systems are the standard. Cultural acceptance plays a crucial role in the success of any waste management system. Understanding and respecting local customs and beliefs is essential when implementing new technologies or sanitation practices. The circle of life: waste, decomposition, and the ecosystem. Don't think of waste as simply something to be disposed of. It's an integral part of the natural cycle of life, death, and decomposition. When managed properly, waste can be a valuable resource, returning nutrients to the ecosystem and supporting a diverse web of life. Consider composting. It's a natural process that mimics the decomposition of organic matter in nature. Microorganisms, insects, and worms break down food scraps, yard waste, and even human waste into nutrient-rich compost, which can then be used to enrich soil and support plant growth. Even in wastewater treatment plants, the decomposition process is harnessed to break down organic pollutants. Bacteria and other microorganisms feast on the organic matter in sewage, converting it into harmless byproducts. This biological process is essential for removing pollutants and returning treated water to the environment safely. Poop power, energy from waste. Here's a thought that might make you chuckle. Your poop can help power our homes and cities. It's true. Wastewater treatment plants are increasingly harnessing the power of poop to generate biogas, a renewable energy source. Biogas is produced through the anaerobic digestion of organic matter, like sewage sludge. In the absence of oxygen, microorganisms break down the organic waste, releasing biogas, a mixture of methane and carbon dioxide. This biogas can be used to generate electricity, heat homes, or even power vehicles. It's a sustainable and environmentally friendly way to reduce our reliance on fossil fuels and create a more circular economy. The future of waste innovation and sustainability. The future of waste management is bright, driven by innovation and a growing awareness of the need for sustainability. From smart toilets that analyze our waste in real time, to decentralized treatment systems that empower communities to manage their own waste, the possibilities are endless. Nanotechnology is being explored to develop advanced filtration systems that can remove even the smallest contaminants from water. Artificial intelligence is being used to optimize treatment plant operations, improve efficiency, and reduce costs. The goal is to move towards a circular economy, where waste is no longer seen as a problem, but as a valuable resource. By embracing innovation and prioritizing sustainability, we can transform our relationship with waste and create a healthier and more sustainable future. From disgust to data, embracing the power of poop. It's time to rethink our relationship with waste. What we once considered disgusting and disposable is actually a treasure trove of information and a valuable resource. By embracing the power of poop, we can unlock new frontiers in public health, environmental protection, and resource recovery. Wastewater epidemiology is revolutionizing our understanding of community health, providing early warnings of disease outbreaks, tracking drug use patterns, and monitoring environmental pollutants. Advanced waste management systems are transforming treatment plants into resource recovery centers, generating energy from waste and extracting valuable nutrients. It's a paradigm shift from disgust to data, from waste to resource. By changing our perspective on poop, we can create a healthier, more sustainable, and surprisingly fascinating future. So, next time you flush, remember the hidden power of what you're sending down the drain. It's more than just waste, it's a reflection of ourselves and a resource for the future.